All right, we are in chapter 6. Chapter 6 is graphing exponentials. So we have graphed a straight line, and an exponential has a certain look, and I'll draw some on top. So an exponential means that the exponent is the variable. Okay, so it's in this format. Y equals A times B to the X. Now these are going to be numbers. The exponent is a variable. And that's what I plug numbers in for. 2, 1, -1. So I'm going to first do like y equals 1 times 2 to the X. So this equation here has a 2 as the base. That 2 that's on the base is going to give you a shape that looks like this. The graph goes upward, and it gets really close to this x-axis. The purple line gets really close to the x-axis, but it never touches. It goes on forever to the left. This is, negative infinity to the left, right? And then it goes in an upward slant. This is a whole number of 2 raised to the power of x. This is what an exponential would look like. Upward. An upward slant. This is what I call exponential growth. Then y equals 1. I'm just picking 1. It could be a 2. It could whatever. And then I'm going to put a fraction in. 1/2 to the x. This graph is called exponential decay. Decay is a slant downward. And the purple line gets super, super close to the x-axis, but it never touches. Closer and closer and closer, and it goes towards positive infinity to the right. Whatever number, the biggest number you can possibly think of, positive infinity. So see how the slant of the line, this one is an uphill, grows, it gets bigger. As I go to the right, it gets bigger. This one, it's a decay. I get lower and lower, smaller, smaller, decay. Growth and decay. That's what the term exponential graphs means. So, I've got a visualization now. Let's practice just some of the math basics. What was 3 to the negative first? You took a quiz on it. And you had to do problems like this. 1/3. I don't need to put a first power. What's 2 to the negative 1? 1/2. Good. What's 2 to the negative second power? 1/2 squared, which is, I have to do it because it's under 5. So I have to actually work it out. 2 squared? 1/4. Nice. Okay. Now 1 through 6 is me just graphing. Y equals 2. No x. That means no slope. This is a vertical, just kidding, sorry. It's a horizontal line. Since it says y equals 2, I'm going to go on the y-axis to 2. Oops. And I'm making a straight horizontal line. Y equals 0 is also horizontal, but the line is at 0. Well, 0 is kind of like my, the same line as my x-axis. Y equals -1. Still horizontal. Go to -1 on the y-axis. Okay? So, 4, 5, 6. This has no y. It's just an x equals. X equals. These are vertical lines. Go to 3 on the vertical. Go to 3 on the x-axis. X equals 3. Make a vertical line up and down. Okay, so x equals 0 is also a vertical line at 0. But it looks like it's the same as the y-axis. Lastly, x equals -4. At the x-axis, go to -4. Make a line up and down. So, we graphed these back in the earlier chapter. We have done vertical and horizontal lines, but here's a recap. I want to go to the back side now. So I have 3 types of graph on the back. I have a linear graph. First, I think that you can plug these in without any hesitation, but pick small numbers, guys. Like some negative, some positive, so that I see the left-hand side of the line and the right-hand side of the line. Well, plug it in, plug it in. 2 times -1. 2 times 0. 2 times 1. 2 times 2. Okay? Table 2. Last warning before I disband you and move you. I can hear your whisperings and whatever. Okay. Plot the points. -1, -2. 0, 0. 1, 2, 2, 4. It's going to be a straight line. Okay. Linear. It's going to be like an x to the power of 1. I'm now going to show you x squared. We haven't done x squared. We're not doing x squared until chapter 8, but I at least want you to see the difference in what these look like. An x squared is called a quadratic. And the shape is a parabola. This is a new word, probably. A parabola is a U-shaped. So let me have you change the table of values so that in the middle we can actually show our math. I put the x values I already gave you. I changed this column to be x squared. What the math problem is, y equals x squared. And then the last column I made a y, so we could get our answer and put that answer in that space. So I'm going to do -2 squared, -1 squared. By the way, this means -2 times -2. And -2 squared means -2 times -2, times itself. That gets you a +4. -1 squared means -1 times -1. That gets you a +1. 0 squared is 0. 1 squared is 1 times 1. 2 squared is 2 times 2. Okay. -2 comma 4. -1 comma +1. Left 1, up 1. Zero, 0. X comma y. 0, 0. Plot that point. One comma 1. Over 1, up 1. 2 comma 4. Over 2, up 4. Okay. So the shape is this U. It's called a parabola. Notice how the sides match up? Like this side and this side are the same on both sides. If I cut a line down the middle, it's the same on the left as it is on the right. And then these ordered pairs, these 1s and these 4, these y values, they match up. 1, 1, 4, 4. 1, 1, 4, 4. This is symmetrical. It's the same thing on the left as it is on the right. Symmetrical. Now, our last type is not linear. It's not a quadratic. This has a variable in the exponent. This is called exponential. I need to write in the middle y equals 2 to the x power. And then I'll put the y. I need to add another section for my table of values. So I have the base of 2 for every single ordered pair. I have to raise it to the -2nd power. 2 to the -2nd. 2 to the -1. 2 to the 0. 2 to the first, 2 squared. We practice these on the front side for this reason. 2 to the negative second. I already did that on the front. What's 2 to the negative second? What? 1/4. 2 to the negative first. 1/2. Anything to the 0 power is? Ooh, 1. So my squares are a little bit wider, but they are hard to see. The photocopy is not amazing. So if I'm only going to go 2 to the left, but 1/4 up, 1, 2 to the left, only a 1/4 up, that means I'm not even going to go to the next box. I'm just going a little bit, teeny bit above the line. One to the left and up a half. 1 to the left and up a half. That's halfway in the box. That's a little bit higher. Just a little bit. A little bit. 0, 1. That's my y-intercept. One, 2. And then over 2 up 4. This slow, gentle curve, I want your graphs to be a curvy. It's never going to touch the x-axis. It's going to go up forever. Now, it gets close, 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 but it never actually touches that x-axis. Even negative 100, it's like even closer. But it just doesn't touch. So, exponential, this one is upward. See how it's going in an upward direction? And I call this exponential growth. Because it's going up. Good job.